Hi, today I want to talk about context-compatible information fusion for scientific knowledge graphs. My name is Hermann Kroll and I'm a researcher at the Technical University of Braunschweig. So let me start with a brief introduction of knowledge graphs. So knowledge graphs are large repositories containing entity knowledge. So typically knowledge is encoded as RDF facts. So for example, Albert Einstein won the Nobel Prize is a fact consisting of a subject, a predicate and an object. Knowledge graphs are used in many applications today. So for example, smart assistants like Siri and the Google Assistants are using them. Besides, there are applications for question answering and knowledge discovery which are using knowledge graphs too. And in this talk I want to focus on scientific knowledge graphs. So a scientific knowledge graph is a knowledge graph containing scientific knowledge. So for example, the world's most largest knowledge graph of medical knowledge is the SemMedDB. It's a knowledge graph of around 19 million different facts, which is harvested from the whole PubMed collection. So knowledge graphs can be built in two different ways. So the one way would be like used in SemMed to have an automatic extraction. So you have a large document collection and then you apply an information extraction technique and harvest as much knowledge as possible and put all together into a single knowledge graph. The other way would be to ask human experts. This way is used for Wikidata, and then these experts enter facts manually and then you put all facts together in the crowdsourced fashion to have a large knowledge graph like Wikidata. In this talk I want to focus on validity. So what does validity mean exactly? So for example, the fact Albert Einstein is an instance of a human or Albert Einstein has the gender male can be used in any discussion, in any answer or in any answer to a query. So the fact is valid in general and doesn't depend on a concrete context. On the other side, if we look at scientific knowledge graph, there are facts which are not valid in general. So for example, the fact that simvastatin causes rhabdomyolysis depends on several conditions. So they use dose, interacting drugs and something like that. So you cannot use this fact in any answer because you have to consider the context if the fact is valid or is not valid. Let me clarify this in an example. If we have a knowledge graph about simvastatin and having, for example, 3 statements about simvastatin. So simvastatin treats osteosclerosis, simvastatin interacts with amiodarone, and simvastatin causes rhabdomyolysis. And then we get a query. The query asks us to answer which are the known adverse effects of a simvastatin treatment for osteosclerosis. Okay, then we might have easily a look at the knowledge graph and see, okay, we can say rhabdomyolysis is a known cause. But this is not valid. If we consider the context, then we would see that the treatments that in the context 2, so simvastatin treats osteosclerosis is one context, and the side effect that simvastatin causes rhabdomyolysis is only observed when simvastatin interacts with amiodarone. So we cannot use the answer that simvastatin is a known cause for rhabdomyolysis in any context. This is a problem if you are working with scientific knowledge graph and if you have facts which are not valid in general. So in this paper we recommend a context-aware information fusion. So if you work with a scientific knowledge graph for concrete application, then you should consider context information. On the one hand, you might use explicit context models like qualifiers or NLE facts, but we have a long discussion in our paper about that. The problem here is that if you have a large knowledge graph like Wikidata and you have to provide context information for any different fact, then you have to ask a lot of experts and then you have to enter many information manually. So this is a large problem here. In this paper, we recommend the user to use an implicit context model. So typically, scientific knowledge is published in a scientific argumentation. So scientific argumentation should contain all the important conditions which which in fact affect the validity of its contained facts. So the scientific argumentation has already all important conditions which make the fact true or not true, or valid, not valid. So we recommend you to do, instead of harvesting facts out of documents and put all together into a single knowledge graph and then use this knowledge graph to build an answer, you should keep the reference to the original documents, and then you can decide on runtime if you have two facts which could form a valid answer. Then you have to have a look in the documents and decide, okay, have both documents a compatible context or not? If they do have a compatible context, then you can fuse the information to form a valid answer. If they haven't a compatible context, then you should reject this answer to don't produce not valid answers. In our paper, we have done large experiments on SemMed. So here's a small example. We have looked in the literature and have a look what experts do with these knowledge graphs. And medical experts use SemMed as a knowledge graph to predict new drug-drug interactions based on a gene. So we use the query and just use SemMed to answer the query. If we just use a plain knowledge graph, then we would have a precision of around 7%, which is not so good. But we assume the knowledge graph to produce all answers which are possible, so we have a recall of 100%. If we restrict the fusion process of different facts to strict document context, and we only fuse information which stem from the exactly same document, then we would have a precision of around 70%, but a recall of around 1.6%. So in a concrete application, we can boost the precision around 10 times here. Because the recall is so low, we design different metrics which estimate if two documents are context compatible or not. So if two documents are context compatible, then you can use the facts of these documents to form a valid answer. If they are not context compatible, you cannot use the facts together in a single answer. So we design metrics upon text like title and abstracts, and we design metrics working on metadata like mesh terms or authors. And like you can see in the bottom of my slide, here are precision recall curves, and if you choose different thresholds, you can decide how important precision is or how important recall is for your concrete application. So this experiment demonstrates that implicit context models are already ready to work and that you can use them in your application. So let me come to a conclusion. If you work with scientific knowledge graphs, you should always consider validity. So there might be facts, like birth dates, which you can use in any context, and the answer will always be valid in general. So there will be no problem for you. But especially if you work with scientific knowledge graphs, and for example in the medical or in medical domain, then you might produce answers which are not valid in general because your facts are not valid in general. You have to consider the context of the facts if you fuse knowledge together. And in this paper, we propose a method for implicit context based on documents or scientific argumentations, which is already ready to use for your concrete application. It works and it is as easy as keeping a reference based to your documents. Implicit context can boost the precision for your application if you need it. So you can decide if precision is important, then choose metrics with a low threshold. If precision is not important, then you can choose higher thresholds. So this is up to you. So I want to thank you for your attention, and if you have any questions, you can contact me on mail or via Twitter. Thank you.